Okay, so the topic that I'm going to teach today is the Peano Baker series, and this series is used to find the solution of the transition matrix of the time variant system. So if we want to find the transition matrix of the time variant system, then we have to use this Peano Baker series. The Cayley-Hamilton series failed for time variant system, so we can't use the Cayley-Hamilton series for time variant. So this is the preferred solution that we have to use to find the time variant. And the time variant system is if our matrix A depends upon some variable t. So let's say we have A is equals to this. So I will explain the Peano Baker series with the help of this example. So in the Peano Baker series, we actually let's say normally our transition matrix E of AT is equals to I plus AT, the series, plus A square T square divided by 2 factorial, and this goes on. So this is for time invariant system, but now we are dealing with the time variant system. So we can't write this as E of AT directly, because now our this T is a dependent. It starts from T naught and it ends to T, because it is now some time variant. So it is not the time invariant. So this E of AT will be represented with some integral starting from T naught to T, and now the integral is on T, so we will write we will use a dummy variable for this AT, so we can write A sigma and integrate it with D sigma. So this is our the E of AT will be represented as this in the time variant system. So this is for TV, and this was for the time invariant, because here our T was not the transition matrix was not the function of, or A is not a function of T, so we can directly plug in the values of A matrix and take the square of A matrix in this equation and solve it for the transition matrix of the time invariant. But for time variant, because now our T starts from T naught to T, so we have to integrate this A, and this sigma is just a dummy variable. It is actually the AT that we used in the time invariant system, and we have to integrate it with D sigma, because we are integrating it to that interval. So let's just assume that we consider the T naught to be 0. So if we consider T naught to be 0, then this integral will be e power 0 to T A sigma D sigma. And now if I open this series, so I will have I plus this is my first term. So this is my first term, so I have to write this term as the first term, and the first term will be integral 0 to T, and I've replaced it with A sigma D sigma. So A sigma is basically the A, and wherever I have written the T, I have to just replace these T with sigma, so we will have the A sigma. But obviously in the series we will have many terms coming onwards, because we will have an integral. This is the first term, and then just like the way we open the exponential series, so if we have e power at, we write I plus at plus a square t square divided by 2 factorial. So here this series will be opened as I plus first integral plus second integral plus double integral plus triple integral. So we'll solve it till third integral. So as we will have three integrals, so we will have multiple these a terms, and we need many dummy variables. So we can write it this sigma 1 as a sigma 1 d sigma 1. So if I write this as this, so this is my first term, and then for the second term 0 to t, this a sigma 1 first, and then I will need this second integral, and the second integral will include a second dummy variable a sigma 2, d sigma 2, and d sigma 1 again, and this limit will be from 0 to sigma 1. So this is my first term, this is my identity matrix, this is my first term, and this is my second term. But to identify the series, the exponential series, I have to find the solution till the third. It's better to find the solution till the third entry, but we can identify with only the two items as well. So it's about the user, that from how many items he can identify which exponential series it is, or we can end up with the solution that might not even include any exponential series. So the third term will be, so just like the second term include double integrals, so in the third term we should have three integrals, and the first integral will be this a sigma 1, and then straight away we will have a second integral a. This will be from sigma 1, and this is a sigma 2, and then we will need a third integral as well. This will be till sigma 2, and we will have a sigma 3, then a sigma 2, sorry, a sigma 3, and now integrate over all those regions. So d sigma 3, d sigma 2, d sigma 1, and this series will go on, will go on. So up till now we have discussed the formula of the time variant system for Peano Baker series, and the formula is whenever we have any question that in which the A matrix have this T, then we can't use Cayley-Hamilton, we can't use Laplace inverse method, we can't use power series method, because now it is the function of time. So we have to use the Peano Baker series or the general solution. So for Peano Baker series, we have studied that we will have A. So in the A, if we replace T with sigma, we will have a sigma 1, and similarly if we replace it with sigma 2, then a sigma, and if we replace it with another sigma sigma 2, then we will have a sigma 2, and if we replace T with sigma 3, then we will have d sigma 3, a sigma 3. So we can, because these are just the demi variables, it is actually A. So now for the question that I've written here, A, so to solve this I need all these three terms, and at the end I will add up these three solutions to get my e power at, which is actually my transition matrix. So if A is this and my first entry is identity matrix, so I know this term. Now I need this term to find out. So if this term is to find out, then a sigma 1 will be 0 sigma 0 0. So this is my term, and this is integrated over 0 to t d sigma 1, and this is my first term actually. So if I integrate this, so it will be very easily 0 sigma 1 square by 2 0 0, and then I have to plug in the value from 0 to t, so it will becomes 0 t squared by 2 0 0. So this is my first term. So actually the first term is this identity matrix. So after identity matrix, this is my first term. So I have obtained this first term. I have to add these two, but I will add all of the first, second, third, and this identity matrix at the end. So first I will obtain all those terms. So in the second term I know that I have to first obtain 0 to t a sigma 1, and what my a sigma 1 is 0, replace t with sigma 1, and then another integral from 0 to sigma 1, and here I need a sigma 2, and in a sigma 2 just replace t with sigma 2 and integrate over d sigma 2 d sigma 1. Okay, so now if I integrate this term, so what I'll get is 0 sigma 2 square by 2 0 0. Obviously this will be answer, and if I put the limits in this after integrated this with respect to d sigma 2 first, I will get this solution, and if I plug in the limit sigma 1 to 0, so this sigma 2 will become sigma 1. So this sigma 2 will be replaced with sigma 1 after putting limits, so we'll have sigma 1 by 2. So I'll have this matrix multiplied with 0 sigma 1 0 0, and then integrated over. So let me just make some space, so because we really know that this thing will be happening here. So I've explained this step, so let me just rub it. Okay, so I've written these two things, and it will be integrated over from t to 0. So I'll integrate this from 0 to t, and here I have d sigma 1. So I need to multiply these two matrices first. So 0 into 0 is 0, sigma 1 0 0, 0 into this is 0, sigma 1 this is 0, 0 into this is 0, 0 into this is 0, 0 into this is 0, 0. So this term becomes 0. So not all the time this will become 0. We will have some solution here most of the time, but I've explained it with a simpler example so that you get the concept. So if you get some answer here, then you have to integrate it with respect to sigma 1, and then you plug in the value in this plug in the limits, so your equation will be in the form of t. So then you will have three terms. First will be the identity matrix, and after identity matrix you will have this first term, then you will have this second term, and after adding all the three terms you will identify either the series. You will know that what series your equation is following. So let's say you get in the first term you have 1, and in the second term you have when you add that you have t, and then in the third you have t square by 2 factorial. Then you don't need to find the third term, because you will know that this series is e power at, and here this a is actually 1. So you can directly say that this series is equivalent to e power t. So similarly, if you have, after adding the identity matrix you get 1, and then in the first entry you get 2t. In the first entry you get 2t, and in the second term you get 4 t square by 2 factorial. Then this means that your series will be e power 2t, because here your a is 2. So you just have to identify. You can identify in 3 terms, you can identify in the 4 terms. So if you have to solve for the third terms, then you should really know that how will you do it. So here in this question we have this second term becomes 0. So we know that if second term becomes 0, then the third will be also 0, then onwards all the terms will be 0. So I'll just explain I'll just show the final answer. So the final answer will be the addition of the identity and the first term. So if we add now the identity matrix and the first term, so we have to add it by entry. So the first entry of the identity matrix is actually, so we have the first term e power at. In e power at solution, the first item that we get is 1 1 0 0, that is identity, and it is added with my first term, and I have obtained the first term as 0 t square by 2 0 0. So I just have to add these two. So this is added to this one, so we'll have 1. This is added to this one, so we'll have t square by 2. So let me just write it here, the final answer, because I don't have that much space. So if we add this with 0, we'll get 1. If I add this with this, we'll get t square by 2. If I add this with this, we'll get 0. If I add this with this, we get 1. So this term is my final transition matrix. So this is my transition matrix. Here it don't follow any series, just like the one I said that we could have a series. So if we had a third term, then in the third term, let's say in the first term we get for the first entry we get 1. For this in the first term, for the first entry we get 2t. For the third for the second for the second term that you have solved, and you get 4t square in the first entry, the 4t square or 2 factorial, then that means that after adding all those three you will have e power 2t. So this is what I have explained. So similarly for all other entries, you have to add all entry by entry, and you will get some series, and that series will be represented with some exponential, and that will be your final answer. So this is all about the Peano Baker series. If you have any problem regarding this Peano Baker series, then just comment it. I will upload more examples as well if you are required. And thank you and good luck.